All right, let's take a look at an example of finding the area of a triangle. All right, so looking at the area of a triangle, all right, let's go ahead and talk about how we find the area of any triangle. Going back to geometry, we know area is equal to 1/2 times the base times the height. All right, so let's draw a picture of this triangle. We're given triangle ABC. So with triangle ABC, now one of our angles is obtuse. So I'm going to draw the triangle somewhat to scale, best I can. So let's draw in a quick sketch of this triangle. So we've got this, angle C here, which is given to be 102 degrees. And let's go ahead and label sides A and B. Doesn't matter, we let this be A and that'll be B. All right, now we know side A will be the side opposite, so that's 90 meters in length. Here's A's length, right, side A. And side B, the side opposite angle B, is 52 meters in length. All right, so now let's look at finding the area of this triangle. So we'll find an area. We need the base and the height to calculate that. Now let's go ahead and draw in the height here. So we're looking at the height of this triangle. Go to the top and drop down as vertical, right, to the base. And of course, dropping down to the base is horizontal, right? We're forming a 90-degree angle. And you can see we're looking at a right triangle here. So we can use some right triangle trig, right, to calculate the height, right, of this triangle. So again, let's talk about that. So our base, well, here's our base. Right, there's the base of our triangle, 90 meters in length. Now let's find the height. So let's go find H. Right, let's find the height. H. All right, to do that, well, let's use some right triangle trig. So the height is this skin piece right here. Now we know from our drawing, right, we know, again, this side here is 52 meters in length, side opposite 90-degree angle. Right, is the hypotenuse. All right, we also know this angle here, right? If it's 102 degrees from here to there, we know this is going to be 180 minus 102. So this is going to be a 78-degree angle, right? So that angle right there is equal to 180 degrees minus 102 is a straight angle. So it'd have to be 78 degrees. So we've got an angle now. So what could we do to find the height of this triangle H? So we know that's the side opposite that angle. So in a right triangle, let's talk about our sine definition. So we know sine, right, is equal to opposite of hypotenuse. So if I asked you what's the sine of 78 degrees, right, you would give me the opposite side, which is H, the height, right? Right here is the opposite side. Right over here, right, that's H. Divided by the hypotenuse, which is 52 meters in length. So again, there's opposite side of 78-degree angle and the hypotenuse. So we can all solve that now. So let's go ahead and solve that for H. So let's go ahead and multiply both sides by 52. And what does H equal? So H is equal to 52 times the sine of 78 degrees. All right, so again, there's our height. Right here of our triangle. So we've got our base, right, 90 meters, and we have the height of this oblique triangle. So let's go ahead and find area. So area is equal to 1/2 times base, which is what, 90 meters, times the height, which is 52 meters, times the sine of 78 degrees, right? We just found height here. So we're plugging in that. So there's base times height. So let's go ahead and figure out what that is. So right now, let's go to our calculator. Let's find out what the area of this triangle is. So let's pull up our TI. So as we do that, let's type it in. So 1/2, so we'll put 0.5, times 90 meters, the base, times the height, which was what, 52, times the sine of 78 degrees. And I get, what, 2,288.87, right? We're rounding to the nearest hundredth. Well, let's go ahead and look at that. back to our problem. All right, what do we have here in our problem? Well, as we look at it, it says round to the nearest meter. So we're taking that in effect, right? Let's go ahead and round that to the nearest meter. So it'd be 2,289 square meters, right? It's area. So there's the area of that oblique triangle, right? Just using geometry. Area is 1/2 base times height and a little bit of trig, right? We used the sine definition, right? So using sine to help us here with this area problem. Now you can see they give you some formulas in our book about area of an oblique triangle. 1/2 BC times sine of A, right? Equal 1/2 AB sine of C equal 1/2 AC sine of B. All that says is you can take any pair of sides in your triangle and multiply by the sine of the included angle and take 1/2 of it, and you'll have your area. But I'm not big on just the formulas. I like to see it, see where it comes from. So again, I wanted to use some geometry and a little bit of trig to prove area of this triangle.